G'day everyone, how are you going? Quick little video on using the product rule. In our course it's not important that you are able to derive the product rule, but you certainly want to be able to understand it, know when to use it, and of course how to use it. So the product rule is taking a function, or rather a function, where it is composed of two functions multiplied together. That's the spot. If you see two functions multiplied together, the product rule can be used. Now it doesn't have to be. Sometimes it's easier just to multiply something out first and then take the derivative. But if it's quite complex in these two functions, the product rule is going to make it a little easier. So what the rule says is to work out the derivative, y dash, we take the derivative of the first one, multiplied by the second, plus the first one multiplied by the derivative of the second. Okay? So essentially what we're doing is taking the derivative of each part and multiplying it by the other part and then summing it up. Here's an example from our book that I'm going to do and work through. Yes, we could multiply this out. It wouldn't take too long, it'd be quite easy, and we could then work our derivative from that expanded version. But let's use the product rule instead. So we're going to say y dash equals derivative of the first. Now this 2x plus 3, let's just have a look at that. 2x plus 3 as a function in its own right, this is the gradient part. That's the part telling me the gradient. Graphing it, wouldn't it cross over at 3 and have a gradient of 2? So it would look something like that. This is the only part that's telling me about the gradient. This part here is just shifting it up or down, but not changing the gradient. So when I take the derivative of this part disappears away, and I just take the derivative of the 2x and I'll get 2. So this is going to be 2 for that part right there. Lots of the other part, 5x plus 1. And in a similar fashion, the derivative of this part is going to work in the same way, just that the equation or the graph would look slightly different. This is going to be plus 5. Lots of the first one, I've written this wrong, I'll follow this here. f of x, 2x plus 3, multiplied by the derivative of this one, which is 5. I was going to write them the other way around. It doesn't matter because you're multiplying them, it doesn't matter which way around you write these two. Let's tidy up, let's multiply this out. We're going to get 10x here plus 2 plus another 10x plus 15. Sum all that up, we're going to get 20x plus 17 would be my answer there. And that's going to be the derivative of that one right there. We could have multiplied it out and then got the answer the same way, but this is a neat way to do it. But I've just spotted I've made a mistake, and I have... No, I haven't. No, I just saw that, I thought I'd made a mistake. No, are we right?
Well, actually, it says we're wrong, but I suspect that you're right because I got the same answer as you, and the book's wrong.
Check this out. See if I got it wrong or right. I think I'm right. I don't think I've made a mistake. What do you reckon, class? Can anyone see a mistake in there?
No.
Maybe.
I think it looks pretty good to me.
That's good.
If you spot a mistake, comment.
Why is it times 5? Yes, that should be 2, isn't it?
I think you are... No, that's okay. Because this, I'm doing the second part here.
Oh, sorry, yeah.
So it's that times the derivative of that, which would be 5.
Yeah.
I think we're okay. If we're not, leave me a comment. Tell me where I made a mistake and I'll tidy the video up and redo it. Hopefully this one helps. I'll do a video of chain rule and quotient rule as well in a similar fashion. Let me know if you want more. Thank you.